Given dy over dx is equal to y minus 1 over x squared, we are asked to solve the particular solution y equals f of x given the initial condition that f of 2 is equal to 0. So step 1, always separate your variables. We'll divide both sides by y minus 1 to move that to the left-hand side, and we'll multiply both sides by dx to move that to the right-hand side. So here we have 1 over y minus 1 dy is equal to 1 over x squared dx. To get rid of our dy and our dx, let's take the integral of both sides. Well, the antiderivative of 1 over y minus 1 is the natural log of the absolute value of y minus 1 plus c, but of course we'll move that plus c over to the right hand side since that's what we have always done. Now we'll take the antiderivative of 1 over x squared. Well, the antiderivative of x to the negative 2, we add 1 to the exponent, giving us x to the negative 1, and divide by that number, which is negative 1. And here we'll include the plus c. Now we don't want to have a natural log in front of our y. So to get rid of it, we will raise both sides to the power of e. So here we have e to the natural log of the absolute value of y minus 1 equals e to the negative x to the negative 1 plus c. Well, the e and the natural log, they cancel out, yielding absolute value of y minus 1. And on the right hand side, we can use our trick when our c is in the exponent. We can rewrite this as e to the c times e to the negative x to the negative 1, since multiplying a common base means that you add the exponents. And of course we can go backwards as well. Well, if we raise e to a constant, that just gives us a different constant. So here we have the absolute value of y minus 1 is equal to c e to the 1 over x, and that's negative 1 over x. Well, let's see here. E to the negative 1 over x is never going to be negative. It's always going to be positive. And c, we can let that always be positive, keeping in mind that we always have to have a positive c. And if we do that, then we don't actually need these absolute values, because absolute value enforces that our function y minus 1 has to be positive. However, the right hand side is always going to be positive as long as we pick a positive c. So let's just get rid of that absolute value. So we have y minus 1 is equal to c e to the negative 1 over x. Now let's make a little note over here that we want c to be positive. Okay. Now at this point we can plug in our initial condition in order to solve for c. And our initial condition is that f of 2 is equal to 0. We'll plug 0 into y, so we have 0 minus 1 is equal to c e. We'll plug 2 into x, that's negative 1/2. This means that c e to the negative 1/2 is equal to negative 1. And if we divide both sides by e to the negative 1/2, we have c is equal to negative 1 over e to the negative 1/2. Of course, we can raise e to the negative 1/2 by changing the exponent to be positive. So we have c is negative e to the positive 1/2. Now, let's plug in our value of c, which is negative e to the 1/2, into our function. So here we have y minus 1 equals c, which is negative e to the positive 1/2, times e to the negative 1 over x. We can group our terms on the right hand side by multiplying negative e to the 1/2 times e to the negative 1 over x. So here we have y minus 1 is equal to, we have negative e to the 1/2 minus 1 over x, because when you multiply the common base, you just add the exponents. And finally, we can solve for f of x by adding 1 to both sides. So f of x is equal to 1 minus e to the 1/2 minus 1 over x. And this right here is the solution to the particular equation with the initial condition f of 2 is equal to 0.